The electric power rating of a device tells us how fast it uses energy. And almost every appliance you buy is going to have a rating in watts somewhere on it, which is a piece of information you can find out. And you should. Because how fast you use energy, the power, and how much time you use the device for, those two things combined can help tell you how much it's going to cost to run the device. So I'm going to go through and look for the power in watts on various appliances in my house. Sometimes it's not given, in which case you should look for the volts and the amps. And we'll talk about how you can calculate watts from that. You're going to do this as part of your assignment as well on devices you have in your house. Here's a pack of traditional incandescent light bulbs. They're rated at 60 watts, 825 lumens. Here's their replacement LEDs. They're also 800-ish lumens, and they're only rated at 9 watts. In my toaster's case, it's here on the bottom, 1500 watts. Please don't turn your toaster over. You will make a mess, so I'm holding this up. So in a microwave, a lot of times you'll find it inside, and here's the sticker. It's very weird putting my phone inside a microwave. And if you look on the far left, right above the volts where it says 120, that's the US voltage that we use, it says kW 0.95. So that means 0.95 kilowatts or 950 watts. This drill is rated 6 amps at 120 volts AC. So we'll do a calculation to figure out how many watts that is once the cat gets out of the way. So if you have the amps, which is a measure of electric current, and the volts, which is a measure of how much energy each charge is carrying, you can multiply them together to get watts, how quickly the device uses power. There's something we don't know called the power factor. This is going to be dependent on the appliance. It's a number that's between -1 and 1. So depending on what that is, the answer you're going to get here is a maximum power, but that's okay. That's really the best we can do without much more testing. So at most, my drill uses 720 joules per second. On this computer, if we look at its regulatory sticker, again, it doesn't tell us the watts, but it tells us the volts in the United States, 115, and the amps, 5. So we'll multiply those two together to find the watts. Here's the inside of my fridge. It's kind of hard to see, but it's hiding right here. 115 volts, amps 7.0. So here's those calculations. At most, the computer would be 575 watts, and the fridge would be 805 watts. Now, it's important to recognize that these are maximum values not just because we don't know the power factor. It's also because that's how much the computer or the refrigerator will use if it's drawing full power. But most of the time our computers are not. They're in some sort of power saving mode and they're not working as hard as they possibly can. And the refrigerator is not running all the time. It only really turns on when it needs to keep your food cool. So these values are not 24/7 values. So sometimes they use power this fast, but most of the time they don't. So here's the various powers I got off my devices. I'm going to ask you to pause the video now and go around your house and try to find 5. Easiest if you can find the watts printed right on the device. If you can't, feel free to take the volts and amps and estimate a maximum power like I did for these guys. When you come back, we'll use those numbers to figure out how much that device costs you per month. So we're going to use your numbers to figure out how much the device costs you per month. But first I want to go into trying to figure out what else matters besides power when we calculate cost. So in order to help you understand what kind of devices use a lot of electricity, we want to have you go through this power company's website, and they've taken all sorts of devices and they've listed them in terms of the power they use, which is wattage, and then the cost per month at whatever rate they were charging when they wrote this. And what we're going to have you do is we're going to have you find the 5 highest power, highest wattage ones, the 5 lowest power, and then the 5 most expensive and the 5 cheapest. and we're going to look for patterns in those different groups. So go ahead and pause this video. There'll be a link to the website, and just go look through it and fill out this worksheet, and then you can start the video again. All right, so I'm not going to give you the answers, but I bet you've already seen some patterns. Highest power devices tend to have something to do with creating heat or motion. And we know both heat and kinetic energy are forms of energy. And energy can't be created or destroyed. So where is it coming from? It's coming from the electricity. So things involving heating or cooling, which is just moving heat around, tend to use lots of power. You probably have also noticed that there's a lot of overlap between list 1 and list 3, but they're not exactly the same. The reason is time is also really important. You expect to find, say, an air conditioner on both lists, because air conditioners not only use a lot of power, but they run pretty constantly. A toaster actually has an enormous power rating, 1500 watts, but you're not making toast all the time, so toasters don't end up being that expensive. So what I want to do is I want to look now at how power usage and time together contribute to how much it costs to run a device. Okay, so now we're at the point where we're going to figure out how much it costs to run each of our devices. So the thing to understand is that what the electric company bills you for is energy use. You're paying for energy. And as we've seen, energy is how fast you use energy or power times how often you use it, or time. So what we're going to be doing is multiplying power times time to get energy. In previous lessons, you have used standard units for all of these, joules for energy, watts for power, and seconds for time. At least on power bills in the United States, the electric company uses different units. Power needs to be in kilowatts, and time needs to be in hours. That gives you the strange unit of kilowatt times hour, which they call the kilowatt hour. And that's what the electric company is going to bill you for. So in order to start doing this calculation, what we're going to do is we're going to take our watts from the previous table that we had for every device, and we're going to copy them into this table. We're then going to convert watts into kilowatts by dividing by 1,000. So for example, for my old light bulb, I'll do 60 watts divided by 1,000, and I'll get 0.06 kilowatts. And we'll just go down the list and we'll do all of them. So I'll let you do that for yours. All right, so there's all my power in kilowatts for all the devices I'm looking at. And the next thing we need to do is we need to figure out how many minutes per day we're using these. Actually, what we really care about is how many hours per month we use. So if you know that off the top of your head, you can skip this part of the calculation and just put that number right in. For most cases, it's easier to think about how much we use it each day. So for both my light bulbs, I think I use them about 6 hours a day, let's say in the winter. Turn them on when it gets dark and leave them on until it's time for bed. So I'm going to put in a 6 for both the hours there per day. My toaster, I don't really think in terms of hours on that. Both my wife and I make toast, I'm going to say 5 minutes a day. So to figure out how many hours per day that is, I'm going to do 5 divided by 60. So that's 0.083. Microwave, yeah, maybe about 5 minutes a day as well. So we'll put that in there too. Won't have to redo the calculation. So these are just my usages. Your house may differ. It's going to depend on how many people you got, how often you use different things. A drill, I don't use my drill all that often, maybe like 2 minutes for a whole month. So I'll just put 2 in here, and we'll do 2 divided by 60. So 0.03. So those are my times. So now what we'll do is we'll multiply by 30, because those are all the hours per day. Except for the drill. I won't bother to multiply that because I really only use it 2 hours a month. So I'll pause this and you can go through and multiply all yours by 30 as well. Alright, so there's all the hours I use them in a month. I multiplied all these by 30 with the exception of the drill because I only use it like 2 minutes in the whole month. So in order to calculate the kilowatt hours for each device, I have to multiply my kilowatts times my hours per month. So for the case of the old bulb, that's 0.06 times 180. So 0.06 times 180. So that's 10.8 kilowatt hours per month. So I'll go through and calculate these for each of my devices, and if you can pause and do the same, that would be great. All right, so that's how many kilowatt hours each of my devices uses each month. So to figure out how much they're going to cost me, I need to know what the current electric rate is. And in Connecticut, where I live, that's pretty easy. We have this website called energizect.com where you can find the rate of every supplier in the state very quickly. In other states, you could look at your electric bill and find out what your current rate is, and I suspect there's other websites like this. So as of today, May 22nd, 2020, the Eversource rate, which is what I use in Connecticut, is 9.41 cents per kilowatt hour. So what we have to do then is multiply that rate by our kilowatt hours. Now there's only one other calculation pitfall here, and that is that 9.41 cents is $0.0941. So you're going to multiply everything in this column by that to find out how much it costs. So final example, my old light bulb, and it's 10.8 kilowatt hours. If I ran it for 30 days right now, times 0.0941, that's going to cost me $1.02. So what I'd like you to do is basically go through and calculate all 5 of your devices. How much are they going to cost you? Okay, so here's my finished table, and it's basically interesting to compare how much different device costs you. A light bulb uses energy much more slowly than a toaster or a microwave, but since these are on much less frequently, they don't end up contributing very much to your power bill at all. Look at my poor drill. Its monthly usage of 2 minutes a month means that it costs less than a penny a month for me to use. So you're going to see pushes for efficiency on things that are on for a really long time, not so much for things that don't get used that often. They don't affect your power bill or the environment nearly as much. One last thing worth commenting on here. It may not sound like a lot to run an old light bulb and only pay $1 per month for it, but the new LED bulb only costs you 15 cents a month. If you think of how many light bulbs you have in your house and the fact that you're going to live in your house for many months, those savings of 85 cents per bulb per month really do start to add up. So that's a major reason why using new bulbs is better. There's also serious environmental reasons for that too. So hopefully you now know a little bit more about your stuff and what it's costing you each month. I want to finish this video by showing you a few tools that the government and industry give you to help you figure out how you could save even more money. In recent years, the government and industry has actually made it easier for you to figure out how to save yourself money. For example, on light bulbs, there's now actually a nutrition label, and it really can kind of tell you what's important. So if you look at the nutrition label, right where calories would be if it was food, they have brightness, which is lumens. So we could see that these two bulbs are approximately equivalent in that. They can't tell us how much it's going to cost us to run per year for every bulb because it matters how much you're going to use it. So they make an assumption that you're going to use it for 3 hours a day, and they pick a energy rate that's kind of normal. Obviously, it's going to depend on where you live and how much the power company's charging right now. And with that, they calculate a cost. So that can help you make a choice. Every appliance you buy also is going to come with one of these stickers on it called the Energy Guide sticker. And this was invented really to shame the companies to start building more efficient appliances. If you went to the store and didn't know anything else about air conditioners, for example, you might just pick the one that looks the nicest. But really what matters for you is how well does it work and how much does it cost. So for every device you buy, every appliance, usually it comes with this sticker. And what they do is they compare the one you're buying, how much it costs to run for a year, versus all the other appliances in that category. So they're not comparing this air conditioner to one that's a lot bigger or a lot smaller. They're comparing it to ones that pretty much have these specs. And apparently I bought a pretty good one. The other ones in the category range from $66 a year to $115 a year, so I bought one of the cheapest ones. So that kind of stuff can help you save money if you pay attention. There's really no reason to buy that $115 per year one, and this kind of arms you with the ability to not waste that money. All right, so I hope what you got out of that was that you can calculate something's energy usage by multiplying its power times time, and that once you have the energy in kilowatt hours, you just multiply by the rate, and then you know how expensive it is for that device to be used that month. I hope you also figured out how to save yourself money by telling how expensive your devices are going to be to run each month. And I wanted to leave you with kind of a funny picture I took a couple years back. I don't think I'd want to eat these churros because those higher power usage incandescents, the energy that wasn't going into light was actually going into heat. So you could actually use a heat lamp not just to light up food, but to make it warmer. And whoever decided they wanted to save electricity by putting a money-saving bulb in there, I think kind of missed the point. I suspect those are pretty cold and maybe not so safe to eat. So obviously you need to make sure you get the devices that do what you expect them to do.